This lesson is about graphs of exponential curves. We want to see what is an exponential curve and what its equation will look like. If you get any equation in this form where y equal to a number to the power of x, then you have an exponential function or exponential graph. For example, if you have y equal to 2 to the power of x, y equal to 5 to the power of x, y equal to 10 to the power of x, these are all examples of exponentials. So here 2 to the power of y equal to 2 to the x to the power of x, and this is an exponential. How do you know it is exponential or not? If your x appears at the power, if your x appears where power is, then you're talking about an exponential. All exponential curves like that will cross your y-axis at point 1. So the y-intercept of them is always going to be 1. As usual, we give some values to x, and using that equation that we have, we get the values for y. The equation was, we are looking for this one is y equal to 2 to the x. So again, you make a table of values. You start from, for x, you start from -3 and go up by 1. -3, -2, -1, 0, 1, 2, and 3. Then you substitute in your equation for each x value and get the corresponding y value. So if I substitute -3 for x, then my y is going to be y equal to 2 to the power of -3. So 2 to the power of -3. But what is that? From our knowledge of indices, we remember that any negative power means a fraction, like that. Where the top is always 1, and the bottom is the same expression without a negative power, just a positive power. So 2 to the -3 was here, I'm going to put 2 to the 3. So that negative is gone. Now I know 2 to the 3 means 2 times 2 times 2, which makes 8. So 1 over 8. So when my x is -3, my y is 1 over 8. Similarly, if I put x equal to -2, y will be equal to 2 to the -2, and if I continue in the same way I did before, I end up with a quarter. And when it is -1/2, when it is 0, when x is 0, y becomes y equal to 2 to the power of 0. And any number to the power of 0 is 1, so y becomes 1. Then when it is 1, y equal to 2 to the power of 1, 2 to the power of 1 is just 2, so 2. When x is 2, y is equal to 2 squared, 2 to the power of 2, which is 4. And when x is 3, y equal to 2 to the power of 3, which is 8. Okay, now my table of values is has finished. If I look at the pattern here, when x is going up by 1, let's see what happens to y. Y is doubling every time x goes up by 1. And here, 1/8 has become a quarter, and a quarter has become half, so doubled. Half has become 1, doubled again. 1 has become 2, 2 has become 4, 4 has become 8. So every time you increase your x by 1, your y doubles. Where does that double come from? Because here the base is 2. That's why. If the base here was 3, then every time the y would have been triple. Okay, now with these values, we can plot them. X is minus 3, x is minus 3, y is 1/8. So that's 1/8, just tiny bit over the x-axis. X is minus 2, y is a quarter, x is minus 2, y is a quarter here. This is 1, that's a quarter. And x is minus 1, y is half. X is minus 1, y is half here. That's my point. X is 0, y is 1. X is 0, y is 1. That's the point. X is 1, y is 2. X is 1, y is 2. X is 2, y is 4. And x is 3, y is 8, which I haven't shown here. Okay, now we connect all these points, we get this curve. So that shows how an exponential curve will look like. As you see, it always goes through y equal to 1 on the y-axis, or its y-intercept is 1. It starts off very flat, but it becomes steeper and steeper. And in practice, the increase of population of human or some bacteria or some animals follow this pattern. So initially it goes slower and then it increases suddenly. And with COVID-19, which we are having now, if they didn't take any measures like lockdown and all that, that would have been increasing. The number of people infected by that would have gone exponentially. And every day we would have got 27 times, as they say, of the previous day. So if the first day, for example, was 27 people infected, on the second day you have 27 times 27, 27 to the 2. On the third day you have 27 to the 3, and so on. So it takes only less than a month to spread for the whole population of, say, Australia, for example. So that is how exponential curves look like, and in which cases we can see them. Thank you for your attention.